Today I'm going to solve homework 3, problem 14. Prove that the limit as x approaches 0 of the square root of 4 minus x equals 2. First of all, we have to refer to the definition of the limit, so I'm going to go ahead and read that. For a function f of x that is defined in an open interval about c, except possibly at c itself, the limit of f of x as x approaches c is the number L if for every number epsilon is greater than 0, there exists a corresponding number, delta is greater than 0, such that for all x, 0 is less than the absolute value of x minus c is less than delta, implies that the absolute value of f of x minus L is less than epsilon. So the two parts of this that we need to remember are 0 is less than the absolute value of x minus c is less than delta, and the absolute value of f of x minus L is less than epsilon. And once we find our greatest values for delta and epsilon, then all of the smaller values are also going to be contained. So we can go ahead and plug into this second equation because we have, well, not only do we have c, which is 0, but we have f of x and we have L. So the absolute value of root 4 minus x minus 2 is less than epsilon. Well, we can take out the absolute values and make it negative epsilon is less than the square root of 4 minus x minus 2 is less than epsilon. And then when we add 2 to all of the sides, we get 2 minus epsilon is less than the square root of 4 minus x is less than 2 plus epsilon. Now we get to square all of these in order to remove the square root. So 4 minus 4 epsilon plus epsilon squared is less than 4 minus x is less than 4 plus 4 epsilon plus epsilon squared. All of these have 4s, so we can cancel these out. And so now there's only one thing left to do. We need to divide everything by a negative 1 in order to get rid of this negative sign right here. 4 epsilon minus epsilon squared. Oh, sorry. Okay, we need to change the signs because we divided by negative. So that's greater than x, which is greater than negative 4 epsilon minus epsilon squared. So now we have to plug these into our other inequality in order to find the greatest possible delta. So 0 is less than x minus c, which is less than delta. And since c is 0, really it's just x. Well, this is x right here. So what we're really doing is trying to find the largest value of delta. And so I'm going to draw a number line to help visualize that. Apologies for the bad camera skills. Okay, sort of. Alright, so we're looking for the delta that's farthest from 0. Well, our options are, they both involve negative epsilon squareds. So we're going to go ahead and say that this is negative epsilon squared. And then there's one that's minus 4 epsilon. And then there's one that's plus 4 epsilon. Well, as you can see, the one with the minus 4 epsilon is going to be farther from 0. And so, because that's larger, we're going to set that as our delta. And there we have our largest delta, which proves that the limit of the square root of 4 minus x as x approaches 0 is equal to 2.